Okay, so this is the first unit the first section for Unit 4, and it's all about classifying polynomials. I kind of crossed out the rest because we're actually going to look at graphing them and end behavior in the next unit. So this is just a lot of classifying and identifying vocab. So first of all, a polynomial is an expression where the exponents are whole numbers and the coefficients are real numbers. So those are the two qualifications that make it a polynomial. The degree is the largest exponent of the polynomial. So degree is just another name for exponent. Leading coefficient is the number in front of the first term when written in standard form. So leading coefficient is a number. Constant term is any number without a variable. And standard form is written when the polynomial is written in descending order, or that's from highest exponent to lowest exponent. So highest exponent to the lowest exponent, then we can say that it is written in standard form. And when it's in standard form, the number out front is the leading coefficient. So here's an example of a polynomial. It has whole number exponents, 2, 3, and then there's a 1 with the last variable here. It has real number coefficients, and so to write it in standard form, you would write that in from highest exponent would be the x cubed, so negative 2x cubed would come first, plus 3x squared, and then plus 4x. That would be in standard form. Then the number out front of the term with the highest exponent is negative 2. That's our leading coefficient. And we would say that the degree of this polynomial is a degree of 3. Now the degree of 3 does have a special name. We're going to go down here and label those. So if we want to name the polynomial by degree, if it has a degree of 0, we call that a constant. Constant. An example of a constant polynomial might be y equals 5. There are no variables, it's just one number. First degree polynomial, those you're familiar with, those are called linear. They make a line that's like y equals 3x or 3x plus 2. The highest exponent here is a 1. Remember, x to the first we just write as x, but the exponent is implied that it's a 1. Second degree, those are our quadratics. Those are our x squared, like y equals 2x squared plus 6x plus 5. And you can remember if you have a quadratic equation that looks like this, you use the quadratic formula to solve it. So that's where the name quadratic formula comes from. So it's a quadratic equation. Third degree is called cubic. That's when you have anything to the highest degree is 3. So like x cubed. Fourth degree we call quartic. That's anything like x to the fourth, and it could be anything after that, x to the fourth plus whatever. When it's a 5 degree or higher, we just use nth degree here. So for example, if I have like y equals x to the 7th, we would call that a 7th degree polynomial. So we just replace the n with the highest degree if it's 5 or more. Okay, name of polynomials by number of terms. So first of all, terms are like 3x squared plus 6x. This has 2 terms. The terms are separated by the addition or subtraction. So this example would have 2 terms. If a polynomial has one term, it's called a monomial. Mono is the prefix for one, so monomial. Like y equals 7. It's just one term. It's a constant monomial in that case. Two terms, like a bicycle has two wheels, it's a binomial. Bi means two. So a binomial would be like x plus 6. X and 6 are two terms. It's a binomial. 3, like a trike, has 3 wheels. It's a trinomial. Tri means 3. So we factored a lot of these quadratic trinomials that looked like this. X squared plus 3x minus 10. So x squared, 3x, and negative 10 are all 3 separate terms. So it's a trinomial. It'd be a quadratic trinomial because it's a degree of 2. 4 terms, we call that a quadrinomial because quad means 4. Quadrinomial. So that it would be like x cubed plus 2x squared plus x plus 6. So 4 terms. Anything that's 5 or more terms is we just refer to it as a polynomial. So that might be like 7x to the 6th plus 5x to the 4th minus 3x cubed minus 2x plus 7. So 1, 2, 3, 4, 5 terms or more is just a polynomial. So decide whether it is a polynomial. And if it is, write it in standard form. State its degree, name by degree, and name by number of terms, and then also leading coefficient. So in A, remember to be a polynomial, it has to have real number coefficients and whole number exponents. Whole numbers are 0, 1, 2, 3. So you can't have negative numbers. That would be an integer. You can't have fractions, no x's in the exponent, etc. So A is not a polynomial because you have a negative exponent. And then let's see, B, this is a polynomial. I have whole number exponents, 3 and 4, and real number coefficients. My coefficients are negative 0.8, 1, and then I have a negative 5 as a constant. So those are all real numbers. There's no imaginary numbers. So to write it in standard form, you put highest exponent first. So the positive x to the 4th would come first, then the negative 0.8 x cubed, then the negative 5. So notice that I kept the negative with the 0.8 and the negative with the 5. I just changed the order. Okay, state its degree. It's a degree of 4, which means that it would be called a quartic. And it's 1, 2, 3 terms, so it's a trinomial. So quartic trinomial. And the leading coefficient is 1 because it's like there is a implied coefficient. It's an x to the 4th. There's 1x to the 4th. Okay, C. So I have an exponent of 1 here, 4 and 2. So those are all whole numbers. So that checks out. Then I have negative 1 coefficient, square root of 5, 2, and a constant of negative 7. So those are all real numbers. Again, no imaginary. The square root of 5 is a real number. It's just irrational. So this is a polynomial. Write it in standard form. It would be f of x. The highest exponent is x to the 4th. So square root of 5. Square root of 5, I meant to write. X to the 4th comes first. Then positive 2x squared. Then negative x minus 7. This, again, is a degree of 4. It has a, so it's a quartic. And there's 4 terms, so it's actually a quadrinomial. And it has a leading coefficient is the square root of 5. So we classify it by the degree, number of terms, and then identify some key pieces. All right. The last thing for today is just evaluating what is the value of this function when x equals -1, which means I want to find what is f of -1. So wherever I have an x, I'm plugging in -1. And then I'm just going to follow my order of operations to solve it. So you're going to do exponents first, all of these exponents first. So -5, and then -1 to the 4th power is +1. -2, -1 to the 3rd power would be -1, because you're going to have -1 times -1 times -1. You're going to end up with 3 negatives, so that's a negative answer. -1 squared, 2 negatives make that a +1. And then I have plus 2 times -1 and -3. So now I'm going to do the multiplication because that comes next. So I'm going to multiply all of these out. So -5, -2 times -1 is +2. -7 times 1 is -7. 2 times -1 is -2, and we get -3 at the end. Then you have to work from left to right. So I just need a little bit more room here. -5 plus 2 is -3. -3 minus 7 would be -10. -10 minus 2 is -12. And -12 minus 3 is -15. So f of -1, the function evaluated at -1, equals -15. And that is the basics for today's lesson. So lots of vocab. So those 2 tables we filled out, those are the things you're really going to want to study and be familiar with for today's lesson.